Okay, Dipanshi, you can start.
In the era of the digital revolution, world is becoming smaller and a lot of new technologies are being launched simultaneously. Whereas in the ongoing saga of the digital revolution, Extend and Adapt has produced ripples of excitement in the industry and academia. Therefore, to make a developed world and to match the speed of these above mentioned changes, joint effort from academia, the research community, and industry are required. We also agree that we live in a period characterized by knowledge-based competitions, in which the most valuable commodities are innovation and information. Countries and regions are competing today to attract and develop successful knowledge-based businesses or industries. Recognizing the importance of research and innovation for human welfare and economic growth. Science knows no boundaries, and research is asked today to deal with issues that are increasing global. Developments in science and technology are fundamentally altering the way people live, connect, communicate, and transact with profound efforts on technical development. I would like to take this opportunity on behalf of DoSCI 2024 and ComSIA 2024 to welcome all the dignitaries, management, organizers, researchers, academicians, and students to the second day program of Doctoral Symposium on Computational Intelligence, DoSCI 2024, and International Conference on Computing and Communication System for Industrial Application, ComSIA 2024, jointly organized by Institute of Engineering and Technology, a constituent college of Dr. APJ Abdul Kalam Technical University, Lucknow, India, School of Open Learning University of Delhi, Shahid Rajguru College of Applied Science for Women University of Delhi and University of Calabria, Italy, sponsored by Springer LNNS Series, SRGE, Scientific Research Group, Egypt, Science and Technology of Image and Telecommunication, Tunisia, Scientific Group of Research and Technology. Publication partner Springer, CEUR Workshop Proceedings, elsewhere SSRN. We would like to express our sincere gratitude for your presence in this ceremony as the gateway to initiation to our scientific program. Overall, more than 1,500 papers have been published, and after a rigorous peer review process, only 213 papers have been registered with acceptance ratio of 14% only. It's time for our first keynote speaker, Professor Guangil Jion. Professor Guangin Jion received a BS, MS, and PhD degree from the Department of Electronics and Computer Engineering, Hanyang University, Seoul, Korea in 2003, 2005, and 2008, respectively. From 2009 September to August 2011, he was with the School of Information Technology and Engineering, University of Ottawa, Ottawa, Canada, as a postdoctoral fellow from September 2011 to Feb 2012. He was with the Graduate School of Science and Technology, Niigata University, Niigata, Japan, as an assistant professor. From December 2014 to Feb 2015 and June 2015 to July 2015, he was a visiting scholar at Centre des Mathématiques et Lire Applications, École Normale Supérieure Paris, Saclay, France. From 2019 to 20, he was prestigious visiting professor at Dipartimento di Informatica, Università degli Studi di Milano Stadle, Italy. From 2019 to 20 and 23 to 24, he was visiting professor at Faculdade de Ciência de Computação, Universidade Federal de Uberlândia, Brazil. He is currently a professor at Intaneo National University, Intaneo. He was a general chair of IEEE SITIS 2023 and served as a workshop chair in numerous conferences. Dr. Jion is an assistant editor of IEEE Transactions on Circuit and System for Video Technology, elsewhere Sustainable Cities and Society, IEEE Access, Springer Real-Time Image Processing, Journal of System Architecture, and Ville Expert Systems. Dr. Jion was a recipient of IEEE Chester Sala Award in 2007, ACM Distinguished Speaker in 2022, the ETRI Journal Paper Award in 2008, and Industry Academia Merit Award by Ministry of SMEs and Startup of Korea Minister in 2020.
Hello, this is Kwang Kil-jeon. Today I'm going to introduce my previous work, which is entitled The Application of AI-based computer vision technology to industry. Um, Due to my personal uh, business, I'm sorry I cannot give a talk online, real time online. Uh, okay. So the first thing is object detection. So deep learning can be object detection is um, based on deep learning can be used to industrial purpose. So detecting defects by type of photographing the bottom of the laptop, which is shown here. And in this case, our role is to detect the scratches. So as you can see, here is the probability, the chance of scratch, which means 87 means 87% of chance that it tells scratch, and the 76 and here is a bolt 91, which means it should bolt must in, and the detection of screwed part is the chance is 91, and we can see some solution with your finger. If you touch the this laptop, and the our computer can detect the pollution part with the probability. So this area is, we say, contaminated area, and we also can do so OCR, optical um, character recognition later. So here is another example that we try to detect the screwed part. If there is no screw, then it is not detected. So it is possible to determine the defective assembly state here, and to detect the air outlet part, which is shown here. And here is the packing area. So if the packing is in or not, and we say here is a scratch area. The second topic is optical character recognition. So probably here we say the Korean character 명지대학교, and each of Korean character or numbers can be read. So this slide shows that let's say this is Icheon, which is located here. So these first two and later two numbers indicate the location of the pixel. So upper left and lower right. So then if we have 2 points, then we can make a rectangular. The OCR has two steps. First step, we need to find where the text exists, and the second step, and what kind of character is actually in. Third one is segmentation. So this process is to segment a significant region in an image separated by pixel unit. So as OCR did, segmentation has two steps as well. In the first step, we have to find the box, which means our goal is to find sneakers or human, then we need to find by YOLO, let's say YOLO program, we need to find where human is. And the second step is we need to differentiate the pixels between the object and the background. The deep learning can be helpful to depth estimation. So until now, the conventional method is that we should use the distance between object and the speed of the light. Then we can see the distance. But in this case, by applying deep learning, and we can see the depth map as shown the right. Here is one example of the segmentation technique can be used for movie. Actually, the reason we did this is that there is a commercial company in Korea, and if is they want to pay more to climax area, and I just simply think which part is climax, and I think when the human face or human body is shown bigger, the large area, then it can be we say it is a climax area. So to do so, we apply the segmentation method and find the area of the actual human. Mm. So here is a very popular classification demo, and as you can see, here is a picture, and then you can apply yellow, and you can find orange or apple, whatever. And here is another thing is super resolution, defog, and derain. What is super resolution? Super resolution is given this small original image. By applying super resolution, we can enlarge the size bigger with good performance. And the defog and the derain is that by applying defog and derain, we can remove the fog effect and rain effect. So here's the example. The left picture is a lower resolution. So we say this is the result of without super resolution, and the right one, the much cleaner. So we say it is super resolution. And the upper two images shows the result of without rain. So we can see the rain here effect, and the lower pictures up by using the rain algorithm, we could remove the rain effect. Then why we should use the The reason is that if we use or without use the then performance is different. For example, when we use segmentation that without applying the and as you can see the left image, and it is very hard to see which is the object. But after applying the and we can see the humans and the traffic light, etc. And the lower pictures as well, the detection has been improved. Here's an example of dehazing or defogging. So left pictures are original one, and after defog algorithm, we could find the fog effect removed result. Then why we should apply the fog? The fog can be used first, then we can use other AI technology. So object detection and segmentation, before these techniques, we can apply defogging, and then we could find more objects, and we could see the traffic, the vehicles, and the human, etc. And the object detection can be used in real world thing. For example, here is the wire, and some wire can be reproducible. Some wire must be thrown away. So there is a wire, and probably you are throwing away, but a wire has copper, which can be reusable. So we can do one simulation is that by given after taking a picture of this wire, and it says the computer says it is PE or PVC or PE, which can be reusable or not. Another thing is that when you take a picture, and we can guess the length and the weight. So by using deep learning, and as you can see, here is the result of deep learning, and the deep learning can tell the okay, this one the weight is 15 gram, and the length is 106 centimeter, etc. The drone can be used for flood prediction and monitoring using cameras. So detection example, and the tracking example, and the counting example. So detecting, tracking, and the counting is very important in computer vision. So and this is the area of Gangnam, and we can make a virtual line, and we count how many people passing this line. And the golf ball can be, there are three kinds of golf ball. One is a new ball. Another thing is that a little bit scratched ball. we can say this is repressible, and the other is a very worstable, cannot be reusable. In this work, I made one model which can tell which is the good ball or refresh ball or bad ball. So if the number of defects is less than 3, then I want to say this is a good ball. This is the second example. If the number of defects is in between 3 to 10, let's say here is 4, then we can say this is refreshable. And there are too many scratches or defects, so we say this is a lost ball. So as you can see, the example of scratches, example of too many color errors and too many scratches. So this is a lost ball and cannot be used. Some people, they collect this kind of ball and pretending this is a new ball and they are doing business. And it's a tree as well. Let's say there are some trees like a cypress tree, pine tree, poplar tree, and the willow tree. So when you have the like a drone and your drone is flying and take a picture of the mountain, and we can tell how many what kind of trees there and percentage of the spread tree. And this one was taken with my small drone, which is just a $100 drone. And by applying AI deep learning algorithm, and we can do the segmentation and the detection. Here is an example of terrain. So left picture is the YouTube. I obtained this picture from YouTube, and then I applied the deep learning algorithm, the training algorithm, and obtained the right one. The performance is not very good. The reason is that the model was and the training set for the model and the test images, test video are different. So if we fit the training set and the test set, if they have the similar characteristics, then we expect good performance. Here's a very artificial data set, and the left pictures is the rainy picture, and from here we could successfully remove the rainy effect. And in the same manner, left 3 images are foggy image, and after the fog, we could find the fog image. And yeah, it's the same. The fog result left 2 images, the original one, and we want to make the image more cleaner. So after the fog, we could find the right image. And here is an example of super resolution. So the given small image is enlarged to the right picture. And the drone video without AI. The question here is that this is the image of one company in Korea, which is drone company. And what I want to say is that we want to find where the human is. And if we simply apply the YOLO algorithm, and we make an option only detect the human, then we can find like this way. Once the human is found, then the AI tells the information of the location and the sex or whatever. So we can see the human can be very easily found. Here is another example of the boat detection. The performance is not very good. The reason is that I prepared this one only for apply a grant. So here, your example, as you can see, at least we could detect some boat. Once again, the performance is not good. This is just a test demo. The drone image super resolution, we could apply super resolution in particular area. So let's take a look. This one person, and here is another person. Okay, so when you apply when you apply a super resolution algorithm or conventional method. Conventional method means Microsoft the Paint in your window. Probably you have the paint, and if you enlarge the picture, then the result is shown like this. But by applying super resolution, you could find better images. Um, but to be honest, by simply applying super resolution does not expect good performance. We have to train. We have to train on the particular data set. Then the test set and the training set very similar. Then we could expect a good performance. Here is another example. There are two boats, and upper one, lower one, and the left and the right, which you can see the better performance is obtained by super resolution, and the other is Microsoft Paint result. Here is one example of the drone. In this scenario, I assumed there are two cameras. One is front end, the other is rear end. So the drone is going and taking a picture with the front camera, and there is a bump. So there is the generate. The drone is throw the generate, and after that we see how many people fall and how big how much the building is destroyed. So before and after. The left one is before throwing the generate, and the right one is after throwing the generate. Okay, um, so AI technology, we could use three main vision algorithm. One is the detection and the tracking and the counting. So as you can see, here's the result of detection and the tracking. And of course, we can do counting by as each object has ID. So OCR is also very important topic nowadays. The main problem in Korea is that if you go to customer go to post office and we have to write the address and the content or whatever. But if we the post office just once take a picture and if they can collect the characters correctly, then it is more efficient. For example, this one by just taking a picture and we could find this OCR result. This is quite a good performance. But the problem is that this is it's a print character is okay, but handwriting is still some error. So this is why we need more study in this topic and the tank and the detecting and the tracking. This is a very important topic for a military project. So I prepared this demo for military last year. And the plastic recycling is recently more and more getting important. And let's say the plastic, like a bottle, is in, then we can classify it with the PET, others, or labeled PET, or milk, aluminum can, and the plastic, etc. So by just simply taking a picture, then we can discern the what kind of plastic is in. And the last year, I did another project is a classification of beef part. So I know in India, this is beef is very important. But let me introduce what I've done last year. In Korea, we have 9 grades of beef quality. 1, 2, 3, 4. This is lower number is a bad quality, and higher number is a good quality. Higher number good quality means it has a marbling. So as you can see, white area, we say this is a marbling, and this is and the Koreans like barbecue, so we prefer to higher ranking one. Okay, once the butcher taking a picture of this cow and each person, inspector can give a score of the beef. But sometimes some people has a higher score or lower score, and this is sometimes farmers think this is not fair. So to do so, last year I made one AI algorithm. So just simply taking a picture, and then we can find the meat area and the fat area, like this way. This is the picture of meat and fat, and this one is the data set. So by applying these data set, and we could obtain the model. So the given image, by just simply taking a picture, then fat area and the beef area is obtained, etc. Next one is sun glitter removing. So probably most of you take a picture of the sea or picture of the apple. And when you take a picture of this apple, and probably you can see this white light. This is called sun glitter. And by applying AI, we could remove this effect. So this one removing some glitter, and there is a, let's say, bird and on the water, and taking a picture we could see this is some glitter, and of course we can remove this, and here as well we can remove this some glitter. So let's take a look. Okay, I'm with International University, and in Incheon area, we have the sea. Let's say it is a yellow sea, and there are many ships. And a few years ago, the oil is leaked. So this is why the sea area was very, very polluted. So at that time, we need one machine, which is the oil collecting machine. So this is the oil collecting machine, and I'm working with this company. And the collecting machine needs a camera and to try to find where the oil is. So the machine is going and collecting the oil, and but to do so, this effect, which is sun glitter effect, uh, is bad for the camera. So this is why in this project, I try to remove this sun glitter, then eventually returned the image of the right. In Korea, the professional athlete is very popular. For example, if the parents think their kids are very talented, then they pay money. So some professional, and the professional make a short video like 10 minutes, and this video is distributed so higher school teachers. But in this case, I just assume we can make AI-based shorts. Nowadays, YouTube has shorts like 10 seconds, 20 seconds. So in this shorts emphasizes that the player is playing is more efficiently, for example. So the original picture is shown here. This is sorry, left one. This is the original image, and the right one is by applying AI. So the AI gives the ID to each person, and also this one sports ball. So this is the ball. Then we can tell, okay, so how which player is run how many kilometers, right? So okay, this player run this kilometer, this player, and another thing is that who holds the ball much, so etc. So by simply applying AI, then we can find the performance of each player and etc. So this is very useful for the teachers. Actually, if you are parents and if you want to make this video, I heard one person spend 7 days to make one video. But by applying AI and you can make it short, then probably you can more efficiently have this advertisement video. This is quite at the end of my talk, fruit classification. So this is the result. The epoch is 2. As you can see, more epoch guarantee better performance. It says only 2. And if you are doing this for commercial purpose, then you have to do more than 20 or 50 or even 100 times. If this one has some problem. For example, this one, the ground truth is beetroot. So these are pictures of a beet. But somebody said this is tomato. Somebody said this is mangosteen. Somebody said this one is watermelon. Somebody said this is tomato, watermelon, etc. So pear. Somebody says pear. So this tells that the um that more effort, more training, better model can guarantee better performance. And this is the fish segmentation example. So here is the picture of three fishes. One fish, two fish, and this is shrimp. And here is the result of soft mask. So this one is soft mask, and the soft mask is the result of deep learning, and the soft mask result is 8-bit image. This one is 8-bit image. And what we want to know, what we need is that binary image. So from 8-bit image, and then we can make a binary image, and simply you can multiply between the test sample and the binary image, then you can find the masked image. Nowadays, the segmentation result is relatively good. So, but in this case, the performance is not as good as what you expect, right? So the boundary region is not well segmented. The reason is that in this case I tested only one the epoch. So epoch number is just only one. So if you increase the epoch number like 5, 10, 20, then the performance must be better than this. Okay, so this is the end of the talk. I'm sorry I cannot attend the presentation online. Once again, let me introduce myself. I'm a professor of Incheon National University. My name is Kwang Gil-jeon. So thank you very much for inviting me to deliver a talk. So see you next time. Thank you very much.
Thank you, sir. So moving on further to our second keynote. Associate Professor Dr. Korhan Sengiz was born in Edirne, Turkey in 1986. He received the BSc degree in Electronics and Communication Engineering from Kocaeli University and Business Administration from Anadolu University, Turkey in 2008 and 2009, respectively. He took his MSc degree in Electronics and Communication Engineering from Nakib Kemal University, Turkey in 2011 and the PhD degree in Electronics Engineering from Kadir Has University, Turkey in 2016. Since October 2023, he is at the top world 2% scientist list. Since April 2024, he has been an adjunct professor at University of Zagreb, Croatia since September 2022. He has been an associate professor in the Department of Computer Engineering, İstinye University, Istanbul, Turkey. Since April 2022, he has been the chair of Research Committee of University of Fujairah, University Arab Emirates. Since August 21, he has been an assistant professor at the College of Information Technology in University of Fujairah, UAE from April 2023 to April 2024. He was a senior researcher in the Department of Information Technologies, University of Hedrik Kralov, Czech Republic. Dr. Sengiz is the author of more than 55 SCIE articles, including IEEE Internet of Things Journal, IEEE Access, Expert System with Applications, Knowledge-Based Systems, and ACM Transactions on Sensor Network, 5 international patents, and more than 10 book chapters and 1 book in Turkish. He is editor of more than 30 books. His research interests include wireless sensor network, wireless communication, statistical signal processing, indoor positioning system, Internet of Things, power electronics, and 5G. He is the associate editor of IEEE Transactions on Intelligent Transportation System, IEEE Potential Magazine, associate editor of IET Electronic Letters and IET Networks. He serves several reviewer positions of IEEE Internet of Things Journal, IEEE Sensor Journal, and IEEE Access. He serves several book editor positions in IEEE, Springer, Elsewhere, Wiley, and CRC. He presented 40 plus keynote talks in reputed IEEE and Springer conferences about WSNs, IoT, and 5G. He is a senior member, IEEE, and professional member of ACM. Dr. Census Award and honor include the Tubik-Tuck Priority Area PhD Scholarship, the Kadir Has University PhD Student Scholarship, Best Presentation Award in ICAT 2016 conference, and the Best Paper Award in ICAT 2018 conference. I invite you, sir.
University of Zagreb. Today I will make you keynote about novel routing protocols for wireless sensor networks. In this keynote talk, I will explain you two routing protocols, which are Levka and Maltop Levka, designed by me for wireless sensor networks. And also, I will give you some future directions about our research. So, as an outline, as you see, we will start with the motivation related works, and then I will explain you low energy fixed clustering algorithm, LEFCA, and Maltop LEFCA, which is the extension of LEFCA and designed by us with details. And I will show you some simulation and analysis and conclusions, and also some future works. So, as a motivation, we know that we are using routing protocols for wireless sensor networks for too many research fields, such as disaster relief, target tracking, environmental control, smart cities, and especially in healthcare applications. So, in wireless sensor networks, the main idea collecting some information from the environment or any platform by using sensors and then transmit this collected measured information to the remote base stations. And when we check the literature, we see there are three main approaches for this wireless transmission. These are direct transmission, multi-op routing, and the clustering. In direct transmission, we see that sensors individually collect the measurements and then transmit these measurements to the remote base stations by themselves. In multi-op routing, some sensor nodes can be used as relay nodes or gateway nodes, and by the usage of these kinds of relay nodes, the transmission distances decreasing, and by this way energy efficiency increasing and lifetime of the sensor network improved. And finally, in clustering, there are some cluster partitions, and in each cluster there is a cluster head, and cluster head is responsible to collect information from the sensors and then transmit this information to the remote base station. In our approaches, which are Levka and Maltop Levka, we are using clustering, but in Maltop Levka, in addition to clustering, we are using multi-op routing. So Maltop Levka is a combination of multi-op routing and the clustering. And when we check the literature, we see that there are too many approaches for wireless sensor networks, and but still there are some open research points and some problems. So when we generalize the problems, we see that there are three main problems, which are increase in energy consumption, decrease in network lifetime, and also some additional network overhead. So our designed Lefka and Maltop Lefka protocols trying to solve these problems by using threshold-based fixed clustering approach, and especially at the same time trying to maximize the network lifetime and also minimize the network overhead. And when we check the literature, there are too many related works, but when you are making any research in wireless sensor networks, you need to start with the main protocol, most common, most known protocol, which is LEACH. LEACH is dynamic protocol and designed for dynamic and mobile environments in which the nodes are fully mobile and they are having mobility and the network conditions changing frequently and dynamically. So for mobile environments, leech or leech-based protocols are still, useful. But there are also some problems in leech, which we found that problem that exactly in leech protocol, because of the probabilistic cluster head selection mechanism, for some rounds, there is no cluster head, there is no cluster formation. So because of this, especially for critical applications such as fire monitoring, such as earthquake measurements, healthcare applications, this can be really big problem. Let's say, for example, you are making fire measurements, and let's say for one round or two rounds, you are not getting any information from the network. And let's say the duration between rounds, like 30 minutes. So it means that maybe 30 minutes or 1 hour, you will not get any information from the forest. But in an hour, fire can reach very high levels, and too many problems can happen for trees and other creatures like animals. So that's why our Lefka protocol is very well designed for these kinds of environments, especially static environments, because as I told, Lefka protocol fully using fixed clustering. So if the sensors not moving, Lefka is very nice candidate. But for mobile applications, unfortunately, Lefka is not suitable. So how can we make, for example, Lefka or Maltop Lefka mobile? This is also our still open research problem, and this can be very nice PhD study. If there is any interested PhD student, they are welcome to work with us about this open research problem. So when we check leech, we see that there are two main phases in the protocol. These are setup phase and the steady state phase. In the setup phase, cluster formation, cluster head selections happening. And in the steady state phase, data transmission is done. So when we check also other leech-based protocols like, leech F, like mod leech, DEEC, stable election protocol, there are almost same mechanisms, but for sure there are some differences. But the common thing, they have setup and steady state phases, and in setup phase, preparation, formation of clusters, determination of the cluster heads, and in the steady state phase, data transmission is considered. And these are the most known and well-known protocols. So when you decided to work on wireless sensor networks, especially routing in wireless sensor networks, you have to consider these protocols. When you submit any journal paper or top conference paper, the reviewers probably automatically will tell you that you need to consider these protocols in your comparisons, and you need to show that your algorithm, your approach better than these protocols in terms of some performance metrics. So that's why we also considered all these protocols in our simulations and analysis, and we put them into our comparisons. So we will also see them in the simulation and analyzing results. And there are too many other approaches, we can skip them. So now let us try to understand the some details of our protocol, Lefka and Maltop Lefka. So our Lefka protocol, as we told, it has fixed clustering mechanism. So what's happening? We are, generating partitions, and these are generally equal partitions, and we are electing one cluster head at the beginning for each partition. But in this, idea, at the beginning of Lefka, we are using intelligent cluster head selection mechanism. So what we are trying to do, we are trying to select almost at the center of each cluster partition as a cluster head, and we are trying to start with the best conditions to the protocol. But after that selection of following cluster head, we are using random selection in original Lefka and Maltop Lefka. Also, we have another, ideas, which is selecting, for example, the node which has highest remaining energy, or selecting the node which is closest to the existing ongoing cluster head. And these approaches also have been published in some top conferences of IEEE, for example, IEEE Black Sea Con. And after that, when we determine our clusters, Lefka is ready to work. And in this case, what is happening? Lefka protocol trying to, collect information from the environment by sensors, and then these information transmitted to the cluster head, and then cluster head is responsible to transmit this information to the remote base station. So same in other protocols, we have, as you see, setup phase and the steady state phase. In setup phase, we are building our clusters, selecting our cluster heads, and making, broadcasting of our cluster heads, and providing sensor nodes, normal nodes, to join associated related cluster heads. And then in the steady state phase, as in other protocols, we are directly making data transmission, and cluster heads are responsible to transmit data of the related cluster to the remote base stations. And these are some details. And here, as you see, our Lefka protocol has two main messages in the wireless network. These are cluster head advertisement message and sensor node join request message. So when any node becomes cluster head, he is sending to the own network that he is cluster head by using this advertisement message. And when any sensor node gets this advertisement message, he is sending join request to join the that cluster head. And this is based on the received signal strength. And generally, what's happening here? Sensor nodes joining to the nearest, closest cluster head, and by this way, we are building the clusters and completing the cluster formations. And as you see, these messages broadcasted and reaching all sensor nodes, and while transmitting these messages and while receiving these messages, as we know very well that in wireless communications, you are consuming energy. So when you go back to each protocol, as you see, if you make it for every round again and again, you will have too many messages in the wireless network, and you will consume additional too much energy. And also you will have very high network traffic and network overhead. So as you see, our Lefka by generating fixed clusters, it is also minimizing this network overhead and trying to decrease the number of wireless messages in the network. And after cluster formation, cluster head providing TDMA frame, TDMA schedule, which includes time slots for each sensor member. And as you know, number of time slots or length of this frame is based on number of members in the cluster. And in each allocated time slot, sensor node transmitting his measurement to the associated cluster head. And after that, cluster head, as we told, transmitting message to the remote base station. And the most important, novel and crucial part of LEFCA protocol is cluster head change decision part by using the threshold mechanism. And this idea was the novel idea. It was not tried in any of existing protocols. There are some threshold-based, applications, but exploiting energies of the cluster head and using very low threshold was the novel idea. So this is the main difference and novelty of LEFCA and Maltop LEFCA. So what we are doing here basically, we are putting threshold value, and this threshold value related of the energy of the cluster head. So let's say our cluster head starting with 2 joules energy, and every round it is for sure consuming energy for collecting information, transmitting messages, that's it. And when he reaches to predetermined threshold value, we are changing it with new one randomly in the following round. And this threshold value is very low, and by this way we are exploiting the cluster head's energy, and we are decreasing the number of cluster head changes, and we are dramatically minimizing the network overhead and traffic, and by this way we are obtaining very high energy savings and full network connectivity. So how this threshold value idea or threshold mechanism working, I can explain you from this mathematical equation. This is very important equation for us. This is the equation of energy consumption of a cluster head while transmitting message to the remote base station. And as you see, there are some other, parameters, terms. They are not too much important because they can be changed. We are using some specific values. And when values change, for sure results will change. But here, the critical term is D to BS. So as you see, it is fourth power of this distance. And this D to BS shows us the distance between cluster head and the base station. Okay, and if this is fourth power, it means that you will consume high energy. Okay, and this becomes fourth power when you have the distance which is higher than crossover distance. Because when you have distance higher than crossover distance, your channel propagation model is changing, and because of that, you are starting to consume more energy. For example, for our specific simulation and analyzing parameters, this value is 87 meters. So, for example, if the distance of cluster head to base station is higher than 87 meter, it will start to consume his energy based on the fourth power of this distance. But if it is lower than 87 meter, he will consume by the second power or square of this distance. So all clustering protocols, all wireless sensor networks protocols trying to decrease this distance and trying to change the channel propagation model and make this equation square instead of fourth power. Okay, So, by considering this equation, we can obtain our threshold value mathematically. So by considering this equation, we are considering the worst case scenario to find out how much energy will my cluster head consume for the worst case scenario for one round. This is our main, question here. So we are considering that our, cluster head is at the origin, and this is the farthest node to the base station. And we are considering that there are no cluster formations. There is only one cluster, and the node at the origin is our cluster head, and all remaining nodes are cluster members. So there are also, too many far distance nodes to our cluster head, while also receiving signal from them, transmitting messages to them. Our cluster head will consume the most energy. So for this case, when we make our analysis and calculations, including our specific parameters, we found that our cluster head is consuming approximately 0.005 joules energy for one round for the worst case scenario. So to ensure network connectivity and to secure this value, we decided to use 10 times of this value as a threshold. So for Lefka protocol, predetermined threshold for the specific parameters is 0.05 joules. So as we told, our all sensor nodes are identical and they are starting with 2 joules energy. So we are using our cluster head from 2 joule until he reaches to 0.05 joule. So as you see, we are trying to keep our cluster head as much as cluster head as long as, okay? So by this way, we are making abusement. We are exploiting its energy to minimize network overhead, minimize cluster changes, and maximize our energy efficiency. So, generalization of this threshold value, when you put, this is my packet length, this is my number of nodes, this is my dimensions of network, can be also another very nice PhD study, because as you see, this is numerical value, and it is working on based on specific parameters and values. So generalization of this value and generating generalized equation or mathematical description can be very nice PhD study or maybe postdoc research. And for this problem also, you are welcome to communicate with us, and we can generate a nice research from this problem. If you like mathematics, especially if you have strong and deep mathematical background, we can also try to solve this problem as a research. And let me also summarize you multi-op Lefka in few minutes from this slide, because multi-op Lefka has almost same, initial stages of Lefka, setup phase, all these phases are same, and it is an extension to Lefka protocol, but it has very, important and, unique difference when we compare it with Lefka. As you know, for example, in classic Lefka, now mechanism. For example, the nodes 1, 2, 3, 4 are normal sensor nodes in this scenario in cluster 1. So they are just responsible to transmit their measurements to the cluster head, which is 5. And in normal Lefka, 5, for example, 15, 11, and node 20, they are cluster heads. So they will transmit this collected information to the remote base station. But in multi-op Lefka, for example, node 5, instead of transmitting this message to the remote base station, he is transmitting to neighbor cluster head, which is 11, closest neighbor cluster head to him. And then 11 is responsible to transmit information of cluster 1 and also his cluster, yani cluster 2. So 20 getting the information of cluster 1 and 2. And also, as you see, cluster 15 should send his cluster head 15 should send his information to the cluster head 20. So what happened now? Cluster head 20, cluster head of fourth cluster, became responsible to transmit whole information of the network. So by this way, for example, for especially node 5, cluster head 5, for cluster head 15, 11, we decrease the transmission distances, and by this way, we are saving additional energy. But there is a huge responsibility on, for example, node 20. So if something happens to node 20, what will happen? This is, for example, another open research problem for us. How can we solve this? What kind of solutions, backup solutions can we generate? So this can be also maybe good master research or postdoc research. So again, if you are interested, you can join to solve this problem with us also. And when we check the simulation results, as you see, for example, at the beginning, we told that Lefka starting with intelligent cluster head selection mechanism. So it is trying to select the almost at the center of the clusters as a cluster head instead of random selection at the beginning. So when we compare with random selection and intelligent selection, we see that approximately our intelligent selection providing 10% additional energy savings. So that's why we decided to make it intelligent selection. And also for this intelligent selection mechanism, some machine learning applications, classical approaches like k-means and other ones can be also applied. So maybe better results can be obtained. This is also another open research problem, and it can be, for example, very nice master study. And this is impact of threshold value for Lefka protocol. So as you remember, we are trying to use the minimum threshold value. In other words, maximize the usage of cluster heads energy. So when we minimize the threshold value, our lifetime and energy efficiency increasing because we are decreasing the number of cluster head changes, and by this way we are minimizing the network overhead, number of messages in the network. So that's why we are obtaining additional energy savings. And this is energy map of our Lefka when we compared with Leech protocol. For example, after 3,500 rounds, we see that Leech almost died. There is no, very few number of nodes alive, but in Lefka, it is still possible to collect information from all parts of the network. So, for example, as you see from this figure, that Lefka is very suitable candidate for like fire monitoring, earthquake monitoring, these kinds of systems. And when we go for almost 1,000 more rounds, there is no leech. All nodes dying at leech protocol, but Lefka still surviving and fighting. So almost again all parts of network still you can collect information. So from this figure also we assure that Lefka provides full network connectivity, especially for critical applications. And for example, this is residual or remaining energy of the nodes, and this is comparison of Lefka with other most known, most fundamental protocols, and Lefka has best results when we compared with them. And also, again, this is number of alive nodes, or in other words, network lifetime result. And again, as you see, Lefka has the best performance. And this is network lifetime, average results based on iterations. And these iterations are independent. each iteration has different network distribution, random node distributions, different network, scenarios. And for each random distribution, protocols applied at the same time, and we got the lifetime results of all protocols and Lefka. And when we check the average lifetime of our Lefka, as you see, it has the best performance. And this is also total data transmitted to the base station, or in other words, number of packets transmitted to the base station, because we are working in network layer, so we can talk about number of packets. So as you see, Lefka provides a very nice improvement in total data transmission, and every round it guarantees to transmit number of packets. Yeah, for example, let's say you have 10 clusters, so it means that Lefka will guarantee you like this: 10 packets, 10 packets, 10 packets. Let's say farthest cluster, all nodes died, no worries. From the remaining one, it will be like this: 9 packets, 9 packets. So every round you will collect information from the network 100%. So also we have some additional results about different node densities. For example, when we decrease number of nodes, what will happen? When we increase number of nodes, what will happen? So for all different cases also, we see that Lefka has better performance when we compare with other protocols. And when we put base station inside the sensor area, what will happen? As expected, distance to base station is decreasing. So by this way, for sure, our energy efficiency will increase. And when we compare Lefka with multi-hop Lefka, briefly we can tell that combination of clustering with multi-hop routing in multi-hop Lefka protocol provided us approximately 10% additional energy savings when we compared with Lefka. And as a conclusion, as you see, today we talked about two novel routing protocols, which are Lefka and multi-hop Lefka. Lefka provides additional energy savings and full network connectivity by using fixed clustering, including threshold-based mechanism. And in the threshold-based mechanism, Lefka is providing to exploit the energies of the cluster heads before selecting new one. And multi-hop Lefka also is a combination of Lefka protocols and also combination of multi-hop routing with clustering idea in Lefka protocol. And by this way, as we see from the results, then almost 10% additional energy savings can be obtained by multi-hop Lefka. So also we talked about some open research problems in this talk. So all researchers in master, PhD or postdoc level, also faculty members, are welcome to collaborate with us. Kindly communicate with me via email or LinkedIn, so we can have collaborations, fruitful research, activities together. And it was pleasure to meet with you. Thanks for your interest for my talk, and special thanks to also Dr. Deepak and his colleagues. Thanks for inviting me for this event, and I hope to see you in the future events. Have a nice day. Bye bye.
Thank you, sir. Now I invite Dr. Upendra Kumar sir from IET Lucknow for closing ceremony and vote of thanks. I invite you, sir.
Thank you, Dipanshi. Am I audible?
Yes,
Hello?
sir.
Okay. Okay. Thank you, sir. Actually, it was a wonderful lecture, and very good afternoon to all. I, on behalf of organizing committee of 5th Doctoral Symposium, on Computational Intelligence DoSCI 2024, an international conference on computing and communication systems for industrial applications ComSIA 2024. Feel honored and privileged to get opportunity to propose a vote of thanks on this closing ceremony. First and foremost, it's my honor and privilege to convey my thanks and gratitude to our chief patron of program, Professor J.P. Pandey sir, Honorable Vice Chancellor, Dr. APJ Abdul Kalam Technical University, Uttar Pradesh, Lucknow, for providing opportunity to organize such a big successful program. We are very thankful to you, sir, for your valuable suggestions and encouragement and guidance. I would like to give sincere thanks to our head of IET family, Professor Vineet Kansal sir, Director IT Lucknow, and Professor Payal Mago, Director Campus of Open Learning, Delhi University, for their leadership, continuous support, and guidance and creating such an ecosystem for organizing and smooth conduction of this program. I'm very also thankful to them for gracing us with their kind words. I would like to give special thanks to our General Chair, DUSCI 2024, Professor D.S. Yadav sir, Professor Girish Chandra sir, Professor Vayan Singh sir, for their excellent contribution and support in the DUSCI 2024 and also gracing us with their kind words. Really, they supported in all possible manner to organize this conference. I would like to give special thanks to our head of department, Professor Girish Chandra sir, for creating such a wonderful academic culture and environment in our department, without which it was not possible to conduct such a successful program. I would like to give heartfelt thanks to our distinguished speaker, DSCI 2024 and ComSIA 2024, Professor Giancarlo Fortino, University of Calabria, Italy, for giving his precious time and presence in this program and gracing us with his insightful knowledge. I am thankful to our first keynote speaker, Professor Dr. Robertas, Punas University of Technology, Lithuania. Second keynote speaker, Dr. Lalit Garg, University of Malta. Third keynote speaker, Professor Kwangil Jeon, Incheon National University, Korea. And fourth keynote speaker, Dr. Koran, University of Zagreb, Croatia, for their valuable keynote addresses. Thank you, sir. Today we had an opportunity to hear your thoughts, and this will surely be going to encourage us in our future events. I am very thankful to editorial chair members, Professor Girish Chandra sir, Dr. Mani Chandra sir, Dr. Pawan Tiwari, and Dr. Paru Yadav for providing us their non-stop support and great contribution in USCI 2024. I'm very much thankful to technical program chairpersons, Professor Manish Gaur sir, Professor Amit Khan sir, Dr. Mani Chandra sir, Professor Tapobrat Lahiri sir, Professor Vivek Kumar Singh sir, and other distinguished members for their wonderful contribution in this symposium, USCI 2024 and ComSIA 2024. I am thankful to all the advisory committee members, all the head of other departments of our institute and other institutes also, faculty members and their team to provide valuable suggestions and support. I am thankful to our convener of the program, Dr. Deepak Gupta sir, Dr. Ashish Khanna ji, Dr. Paru Yadav, Dr. Adit Tamparia ji, Professor Ajay Jaiswal, Dr. Sameer Anand ji, and co-convener Dr. Pawan Kumar Tiwari sir, and Mr. Moolchand Sharma, and organizing chair members Dr. Nathan Singh, Dr. Paru Yadav ma'am, for their hard work and great efforts to make this program big successful. I'm also thankful to all the dignitaries, attendees, students connected through via Zoom or YouTube link, participants, researchers present over here. Finally, last but not the least, we have been fortunate enough to be backed by our team of very motivated and dedicated students committee, volunteers, staff members, media persons who have given 24-hour support for smooth conduction of this program and turning this to a great success. Thanks once again to all for making this event successful. Over to you, Dipanshi.
Thank you so much, sir, for your wonderful words. Now I request everyone to turn on their cameras for a group photograph. Everyone is requested to turn on their cameras. Please turn on your cameras. Thank you for joining this wonderful session.
Okay, Adit, you can close the meeting.